Assalamualaikum to Doctor and fellow friends. So today our group will present our project presentation for hydraulic. So we are from group 7, section 3. This is our team members. So the first one is Muhammad RaFiq, SyiMir bin ROZI, and then me, DINA SOFEA binti Muhammad NADZRI, and then Muhammad SYAZWAN bin KAMAL ANUAR. Let's continue with NURUL IZZATI binti AMINAKBAR, and last one is DARREN anak JAMBING. Next, I will present the introduction. So, as we know, water is the most frequent causes of road failure and damage. Groundwater, surface water, and rain runoff from the surrounding area are all sources of water. Controlling the flow of water can help to reduce road damage. Minor damage to the road and its structure can be easily rectified as part of routine maintenance. There are a lot of roads like this that don't have a suitable drainage system. This results in road failure for a variety of reasons, including increased moisture content, decreased strength, mud pumping, crashing of waves, and corrugation, and also bitumen stripping, cutting of pavement edge, and frost action, and so on. So this project is located at the right-hand side of the road that will build at Taman University Pahit Raja. Three types of drainage, which are toe drain, shoulder drain, and berm drain, need to be designed based on specification MSMA.
So for the objective is to analyze the flow direction inside the drain along the plain 75-meter long roadside area on the right, and to analyze the data from calculation requirement for drainage system design, as well as to analyze drainage related factors by using the rational method to determine which direction from the flow is proceeding well.
Okay, methodology. To address the flash flood that occurred in the session of Taman University Pahit Raja, this study used a qualitative methodology to assess the outcome based on hydraulic expertise. Both internal resources and some reference material were used in the research for this project. Online sources could be used to find the data required for the investigation. Okay, as you can see, this is a view from the Google Earth for this project. For the next slide, this is the view of the location for this project. Okay, rational method. Using information of the catchment area, a rational method is used to calculate the peak runoff QP following the rainfall events in Malaysia and many other countries around the world. Runoff peak estimation is mostly done using a rational method. For the small drain catchment, it produces a adequate result and is stated as Q as a peak flow, C is a runoff coefficient, I is an average rainfall density, and A is a drain area. Next is a friction slope. Calculate the catchment area is essential. Google Earth Pro software can be used to determine the catchment area. By using this software, it is also possible to identify the study site elevation profile. Find the empirical IDF curve I. Density, duration, frequency IDF curve are commonly employed to the estimate to the rainfall intensity I for a specific area. The duration refers to the length of the time the rainfall event lasts, which is typically equivalent to the drained area. The selection of the storm frequency, such as 10, 25, 50, or even 10 years, is possible. To minimize the error, empirical equation can be used to utilize the derived rainfall intensity volume from the IDF curve.
Based on the question given, state the name of stormwater drainage design manual required to be used for drainage design in Malaysia. So we propose, due to that, the manual required to be used by authority for drainage design in Malaysia is Urban Stormwater Management Manual for Malaysia, which is also known as Manual Saliran Mesra Alam as MMA in Malaysia. MSMA provided by the Department of Irrigation and Drainage Malaysia under the Government of Malaysia. As we know, MSMA have now the second edition for the manual. So that's all from me. I will pass to the next team members to present. Thank you.
Next question. The reason why flash flood occur at the location. The factor that contribute to flash flood along the Taman University Parit Raja due to topography conditions. As we know, topography is one of the important elements in the flow rate of water. Slope of drainage will be small of the water in the drainage system to flow from higher to lower sections. The speed of water flow will be slower if the drainage system is small, which will causes the discharge rate to be lower.
Okay, next, solid condition also can be considered or one of the important factor that cause flood at the roadside of Taman University Parit Raja. Low infiltration rate of soil will cause flash flood to occur more easily. Without taking rainfall intensity into consideration, area with low infiltration are easily prone to flooding. The study area can be categorized as silty clay type. Also, lack of responsibility and mismanagement of every party, such as visitor enforcement, low legal action towards people who, on purpose, litter rubbish in the drain.
Okay, for the solution of this question is we need to find the friction slope first. Friction slope equals to highest value elevation minus lowest value elevation over length of channel. So we get the S equals to 10 minus 8 over 482, and we get S equal to 0.41 after we multiply with 100%. Next, we can find the weighted perimeter, but first we need to find the elevation height first. So Z over 1 equals to 6.81 over 8, and we will get the Z equals to 0.885. So for the weighted perimeter, P equals to 2y square root 1 plus Z square, and we will get 20.9 meter. Then we need to calculate the area of proposed area. Area is equal to zy square, which is 0.58 multiplied with 8 square, and we get the area is 54.4 meter square. Then we need to calculate the hydraulic radius r. R is equals to A over F. When A equals to 54.5 and P equals to 20.9, we will get the R equals to 2.6 meter. Then we need to calculate the drain flow TD. N equal to 0.05, R equals to 2.60, S equal to 0.0041, and L equals to 482. The equation of drain flow is NL equals to 60R square, 60R 2 over 3, and S to the power of 1 over 2. And we will get the drain flow is 3.32 minutes. By referring the values of many roughness coefficient for open drains and pipes, and tall grass cover equals to 0.05, where N equals to 0.05, L equals to 482, S equal to 0.41. The equation of the T naught equals to 107 multiplied by N and multiply L to the power of 1 over 3 over S equal to to the power of the 1 over 5. T naught, we will get the 50.12. Tc is equal to T naught plus Td, which is 50.1, 50.12 plus 3.32, and we will get Tc equal to 53.42. The average rainfall intensity is mm per hr. Fitting constant for the IDF empirical equation for the different location in Malaysia for low ARIS between 0.5 and 12 months and storm duration from 5 minutes to 72 hours.
Okay, next for lambda k detergent and n. Fitting constant depends on the rain gauge location refer table. By referring to the table above, the selected stations sector JPS Bertapahat because this station is near the Taman U range. The value is shown below. So first of all, we need to search the I. So we use this formula and we got 4.721 mm per hour. So after that, we search discharge cubic with this formula, and also we get 0.036 meter cube per seconds. Okay, for the purpose of new design of channel section, the design of the channel is to prevent any flood occurring to this area. The design of the new channel section must have a bigger value than the value discharge peak. The design section in this project is triangular in shape. The calculation design is 131 and 0.73 meter cube per seconds. So Q design, we use the formula A times 1 over n times R power of 2 over 3 and S power of 1 over 2. So after we insert the value, we got 131.73 meter cube per second. So Q peak and Q design is bigger than Q peak. So this design can hold the float and prevent any other float after this.
Next, I will continue for discussion. According to the calculation and result, a new drainage system designed for Taman University by Raja was suggested in this research to stop flash flood. First, the peak and design value discharge are calculated using the rational techniques described in MSMA second editions. Some informations include the greatest and lowest elevation value to be utilized in the calculation of the friction slope. The drainage system's length 482 meters and the watershed size of 2.89 hectare must be ascertained using the Google Earth performs. The research makes use of runoff (ARI) and Manning-Ronnes coefficient from the MA second editions. Using 0.036 meter cube per second, the average rainfall intensity is estimated and Q peak is established, with the greater Q design value of 131.73 meter cube per second than the original design's 0.036 meter cube per second. A revolutionary triangle-shaped design is success. As a method of reducing flood damage, this design may be employed.
Okay, for the last one is conclusion. For the conclusion for our project is one of the most crucial element of resident care home is drainage system. Effective drainage flow control is required to keep the nature region secure and pristine. Bacteria and other dangerous elements that impact individual as well as the neighbor structure might spread if drainage is not controlled. Okay, after that, filter surface water discharge into the ground may improve groundwater potential while decreasing water volume in the channel and pond. As an outcome, groundwater will be contribute to the water supply, and the drainage system will be able to prevent from storm water. So that's all from us, Group 7, and thank you.